Assalamualaikum and good morning to Dr. Mastida. We are going to present about molecule building and analysis of transition metal complex. Our group members are Nur Alia binti Abdul Jalil, which is me, Muhammad Farhan Shamin bin Shamsuddin, and Irina Shazira binti Irwan. So, we are from group number 3. So, in the first part, a compound of interest of our group is Diammine dichlorido platinum 2 and also known as Cisplatin.
As you can see here, this is a 3D digital model for our molecule. In the center of the atom, there is platinum, which color is grey, connected to 4 ligands, which are 2 ammonia and 2 chloride ions. The blue molecule is ammonia, while the green molecule is chloride ion. The molecular geometry for this molecule is square planar.
So, in part 3, which is the diammine dichlorido platinum 2, its atomic structure including electronic configuration and valence electrons. The atoms present in this compound is platinum, nitrogen, hydrogen and chlorine. So let's go details about platinum first. Proton number of platinums is 78, electron number 78, neutron number 117. Its atomic mass is 195.084, and nitrogen is proton number of nitrogen is 7, electron number 7, neutron number also 7. Its atomic mass is 14.0067. The next one is hydrogen. Proton number, electron number is 1 and neutron number is 0. Its atomic mass is 1.01. The last one is chlorine. Proton number 17, electron number 17, neutron number 18. Atomic mass is 35.453. So next I will continue the atoms electronic configuration, valence electronic configurations and number of valence electrons. So the first one is platinum. Electronic configuration of platinum involved in d orbital, which is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14, 5s2, 5p6, 5d9, 6s1. As we know that platinum is a transition metal, so it involves d and f orbitals. Its valence electronic configuration is in 5d9, 6s1. So it gives the number of valence electron is 10. So the next one is nitrogen. Its electronic configuration is 1s2, 2s2 and 2p3. So its valence electronic configuration is 2s2 and 2p3, thus gives the number of valence electron is 5. The next one is hydrogen. As we all know that hydrogen only have 1 electron, so it gives 1s1 and the valence electronic configuration also the same as electronic configuration, which is 1s1, and gives total number of valence is 1. The next one is chlorine. Electronic configuration of chlorine is 1s2, 2s2, 2p6, 3s2, 3p5. As we all know that chlorine in group 17, so it involves p orbital. Next one is valence electronic configuration for chlorine is 3s2, 3p5. Give a total of number of valence electrons 7 electron.
Now, we will discuss about how the atoms relate to their positions in periodic table. First is platinum. Platinum, or known as Pt, is a transition metal in group 10, period 6. Platinum usually exhibits multiple oxidation states, but we commonly found it in +2 oxidation state. Platinum also able to form complex ions and form various coordination compounds. This is due to its transition metal nature. Second, we have nitrogen. Nitrogen is a non-metal in group 15 and in period 2. Nitrogen has 5 valence electrons, and it can form up to 3 covalent bonds to complete its octet. However, nitrogen also have 1 lone pair. Those 3 bonds is used to form a covalent bonds with hydrogen atoms to form ammonia, or we known as NH3. The third atom is hydrogen. Hydrogen is also known as nonmetal in group 1, period 1. Hydrogen has 1 valence electron and can form 1 covalent bond. Each hydrogen atoms can form single bond with nitrogen in NH3. And last is chlorine. Chlorine is a halogen in group 17, period 3. Chlorine has 7 valence electrons, but it can form 1 covalent bond to reach its octet. As we know, to reach an octet, an atom must have 2 or 8 valence electrons. This also causes chlorine to exist as anion, or we known as Cl-. Of the trends of the properties of the atoms. So, to sum it all up, from atomic size, the larger starts with platinum, and then to chlorine, and then to nitrogen, and then lastly H, which is the smallest. For electronegativity, chlorine has the highest electronegativity, followed by nitrogen, and then hydrogen, and then platinum. For ionization energy, chlorine also has the highest ionization energy, followed by nitrogen, and then followed by hydrogen, and has the same level of ionization energy with platinum. For the bonding behavior, we will talk about it one by one, which is we start with platinum. Platinum will form complex ions with various geometries, which is due to its d orbital electrons. For nitrogen and chlorine, which is a nonmetal will form covalent bonds and involve in coordinated covalent bonding with metal. For hydrogen, it will form simple covalent bond to form a ligand structure NH3, which does not involve directly with platinum.
So for the next part, the type of chemical bond present in the molecule. So the type of chemical bond in this molecule is combination of ionic bond and molecular bond. Partial ionic bond occur causing this molecule are having ionic bond. Other than that, this molecule has molecular bonds consisting of van Waals, dipole-dipole interaction, and hydrogen bonding.
So now I will continue to the next part, which is how the bonding influences the molecule's properties and behavior. Firstly is ionic bonding. The first point is melting and boiling point. The melting point of cisplatin is 270 to 280 degrees Celsius. This high melting point is due to the strong electrostatic attraction between the oppositely charged ions, which is platinum and chloride ions. The next one is boiling point. The boiling point is not commonly reported because cisplatin decomposes easily at high temperature. The next point is solubility. Cisplatin has a partial ionic character in its platinum-chlorine bonds, which enhance its solubility in polar solvents like water, as we all know that water is a polar molecule. And the polar nature of water helps to separate and stabilize the ions in solution, leading to its solubility. The next point is the reactivity. The platinum and chlorine bonds are partially ionic, making the chloride ligands easier to replace in ligand exchange reactions. When ionic compounds like cisplatin dissolve, the ions are free to interact with other substances, leading to various chemical reaction. This property is crucial for its function as a chemotherapy drug. Okay, the next one is covalent bonding, which also influence the molecule's properties and behavior. Let's start with intermolecular forces. The van der Waals forces. These are weak interactions that occur in non-polar molecules. In the solid state of cisplatin is held together by van der Waals forces. These forces are weak but significant enough to influence the melting point of the compound. The second one is dipole-dipole interaction. These forces are stronger and occur in polar molecules. They play a key role in the behavior of molecules like cisplatin, where the platinum and ammonium and platinum chloride bonds are polar. The last one is hydrogen bonding. This is a special type of dipole-dipole interaction. The NH3 groups in cisplatin can form hydrogen bonds with water molecules, which significantly affects the solubility of the compound in water. The next one, let's talk about solubility, which is the ability of a substance to dissolve in a solvent. The polarity of covalent bonds in cisplatin influences its solubility. The platinum NH3 and platinum chloride bonds are polar, meaning they have distinct positive and negative ends. This polarity allows the compound to dissolve in water and other polar solvent because polar dissolve in polar. So, cisplatin will dissolve well in water due to the hydrogen bonding and dipole-dipole interaction that occur between the molecules and the solvent. Lastly, let's consider reactivity. The reactivity of a molecule is influenced by the bond energy and bond length of its covalent bonds. Generally, single bonds are longer and weaker compared to double or triple bonds. In cisplatin, the covalent bonds present influence its reactivity. Molecules with many single bonds like this one, cisplatin, tend to be less reactive because these bonds are longer and require less energy to break. Therefore, the bond energy and length are key factors in determining how the molecule will react under different conditions.
So for the next part is the real world application. Cisplatin has many benefits in daily life, especially in the field of medicine. Cisplatin is one of the most effective and widely used drugs for treating various types of cancer, including testicular, ovarian, bladder and lung cancers. So, how cisplatin can cure cancer? What is the mechanism? The mechanism is cisplatin binding to DNA in cancer cells, causing DNA cross-linking and apoptosis, which inhibits cancer cell growth and proliferation.
These compounds act as materials in science. My first point is platinum as catalyst. Platinum is widely used as a catalyst due to its exceptional properties because it is highly active, stable, and resistant to corrosion. Platinum-based catalysts play a crucial role in various chemical reactions. And the next one is proton exchange membrane fuel cells, also called as PEMFCs. These fuel cells use hydrogen as a reducing agent and air as an oxidizer to directly convert chemical energy into electrical energy. They are environmentally friendly and exhibit high energy conversion efficiency.
Combination therapies as its real-life application. Cisplatin is often used in combination with other chemotherapy agents. This is because first, the benefits is to enhance therapeutic efficiency, and two, reduce the likelihood of resistance. Our antibodies usually will develop resistance towards the medication that we will take. Thus, cisplatin is important as it will stop the resistance and actually makes the medication can completely absorb by our bodies. Other than that, combining cisplatin with drugs like paclitaxel or gemcitabine has shown improved outcomes in cancer treatments. This is like what I have explained because this is to avoid the resistance of the antibody or the body towards the medication. So, when you add cisplatin to the drugs, to the medications, the medication will improve slightly better.
That's all from us. Thank you, Dr.